Welcome to Dark Sky Dive, where we explore the engineering marvel that has redefined our view of the cosmos forever. Back in the late 1970s, personal computers were rarer than spaceships, and the internet did not even exist yet. Humanity was still debating whether a space telescope was truly necessary or just a waste of precious financial resources. Despite the skepticism, an audacious project was launched, aiming to place a massive observatory high above our planet's atmosphere. That ambitious project was named the Hubble Space Telescope, a machine that would soon become a legend of modern science. No one at that time could have ever imagined that a machine designed with 1980s technology would last decades. It became the greatest scientific icon of humanity, enduring for over 30 years in the harsh environment of outer space. But why did we need to go to space? On the ground, even the largest telescopes are severely limited. The Earth's atmosphere distorts light, causing the air to vibrate and making the night sky never truly still or clear. Water vapor absorbs light, and atmospheric turbulence acts like a blurry lens that we can never wipe clean. The only solution was to escape the atmosphere entirely and place our eyes where the air could not interfere. Hubble was designed to fly at an altitude of over 500 kilometers, orbiting the Earth every 96 minutes. It observes the universe in near absolute silence, capturing light that has traveled for billions of years without distortion. The idea sounds simple today, but turning it into reality back then was a challenge far beyond normal capabilities. Hubble was designed for an unforgiving environment where failure was not an option, and repairs were thought to be impossible. It has to withstand temperatures ranging from minus 150 to plus 120 degrees Celsius, constantly. It must survive the violent vibrations of launch and operate continuously in a high radiation environment without breaking down. All of these complex problems had to be solved using electronic technology that is now over 40 years old. The computer on board Hubble is millions of times slower than the smartphone you are currently holding in your hand. Its memory is extremely limited, but it was designed with one primary goal: to never crash under any circumstances. In space exploration, stability and reliability are always more important than processing speed or advanced features. Hubble uses a primary mirror with a diameter of 2.4 meters, which is the heart of the system. It may sound small compared to modern ground telescopes, but at that time, it was an absolute engineering masterpiece. The mirror was ground with extreme precision because even a microscopic deviation would render the telescope completely useless. Engineers spent years polishing the glass, believing they had created the most perfect optical surface ever made by humans. However, after Hubble was launched into orbit in 1990, the worst possible nightmare became a reality for NASA. Scientists discovered that the primary mirror had been ground to the wrong shape by just a few micrometers. It was an error smaller than the width of a human hair, but enough to destroy the focus. The images returned were blurry, and the most expensive scientific instrument in history seemed to be a total failure. Hubble quickly transformed from a symbol of ambition into a symbol of technical failure and public embarrassment for NASA. But what made Hubble different was that it was designed from the start to be repairable by astronauts. This was a revolutionary decision, allowing engineers to plan a rescue mission instead of accepting a total loss. Instead of bringing Hubble back, they decided to turn it into a machine that could be upgraded in space. In 1993, astronauts embarked on one of the most daring space missions ever attempted in history. They flew to Hubble, captured it with a robotic arm, and conducted repairs directly while orbiting the Earth. The astronauts installed a new optical system that acted like a pair of corrective glasses for the telescope. They did not replace the mirror, but instead corrected the light path before it reached the scientific sensors. When Hubble opened its eyes again, the universe appeared with a clarity that humanity had never seen before. Throughout its life cycle, Hubble has been visited multiple times by space shuttles for maintenance and critical system upgrades. During each visit, new cameras were installed. Sensors became more sensitive, and computers were replaced with better versions. The electrical systems were upgraded, ensuring the telescope could continue to operate far beyond its original life expectancy. The strange thing is that the main body structure from the 80s still functions perfectly despite the harsh environment. Hubble is like a vintage camera that is continuously fitted with the most modern lenses available to science. Why does this old technology still outperform many modern designs? The answer lies in its core design philosophy. Hubble was built with a large margin for error, redundant systems, and an extremely durable mechanical structure. It was not optimized to be the lightest, the fastest, or the cheapest machine to build at that time. It was optimized for longevity and reliability, a mindset very different from the disposable consumer technology of today. Hubble is not just a scientific device. It has shown us nebulas where new stars are being born. It captured distant galaxies, helping us measure the exact age of the universe and understand its expansion rate. It changed how humans view their place in the cosmos, making the infinite universe feel a little closer. Every image from Hubble is the result of classic technology, durable design, and decades of human patience. In the modern era of NASA, Hubble serves as a powerful reminder for all future engineering projects. It proves that the most advanced technology is not always the newest or the most shiny gadget available. Sometimes, the most timeless creations are those designed simply to last the longest and endure the hardest trials. Hubble is getting old, and its systems are degrading, but its legacy will never fade from human history. It proves that humans can build machines that span generations, and that knowledge has no expiration date. Amidst a world of rapidly changing technology, Hubble still orbits Earth, quietly looking deep into the universe. A machine from the 1980s is still telling us the story of 13 billion light-years ago. Let us look back at the specific engineering decisions that made this miracle possible in the first place. The wiring harnesses were hand-woven, designed to resist the corrosive effects of atomic oxygen in low Earth orbit. Atomic oxygen is highly reactive and can eat away at materials, a threat that engineers had to neutralize. To point at a distant star, Hubble uses gyroscopes that spin at 19,000 revolutions per minute constantly. The pointing stability is equivalent to holding a laser on a coin 200 miles away without shaking. It moves not by using thrusters, but by spinning reaction wheels, preserving the pristine environment around the optics. The fine guidance sensors are so sensitive they can detect the sway of a firefly in Tokyo from Washington. Data transmission was another hurdle, requiring a network of relay satellites to keep Hubble connected to the ground. Without this relay network, Hubble would be unable to send its massive images back to Earth for analysis. Original onboard storage was on magnetic tape recorders, mechanical devices that were prone to wear and tear. These were eventually replaced by solid-state recorders during servicing missions, eliminating moving parts and increasing reliability. Power is stored in nickel-hydrogen batteries, which allow the telescope to operate while passing through Earth's shadow. These batteries have survived tens of thousands of charge cycles, a feat that modern phone batteries cannot match. Unlike the new James Webb Telescope, Hubble observes the universe primarily in visible and ultraviolet light spectrums. This capability allows it to see stars and galaxies exactly as our human eyes would see them, only better. It monitors the weather on other planets in our solar system, tracking storms on Jupiter and seasons on Saturn. Before we sent probes to Pluto, Hubble provided the best maps available, guiding the path for future explorers. In 1994, it watched a comet smash into Jupiter, a rare event that awed the entire world. Hubble data is open to the public, allowing anyone with an internet connection to explore the universe's secrets. Many of the most famous images were actually processed by amateur astronomers using the raw data archives available online. The archive contains over 1.5 million observations, a treasure trove that will be studied for decades. More than 19,000 peer-reviewed scientific papers have been published based on data collected by this telescope. Its most critical mission was to determine how fast the universe is expanding, a number known as the Hubble constant. Before Hubble, we did not know if the universe was 10 billion or 20 billion years old. Thanks to its precise measurements, we now know the universe is approximately 13.8 billion years old. It also confirmed that supermassive black holes exist at the center of almost every major galaxy in the universe. Hubble helped map the invisible dark matter that binds the universe together by observing how light bends around it. This phenomenon, called gravitational lensing, allows Hubble to use nature's own magnifying glass to see even further. It is hard to believe that this instrument of discovery started its life as a national embarrassment and failure. The repair mission proved that with enough determination, humans can fix even the most impossible mistakes in space. That success restored faith in NASA and paved the way for the construction of the International Space Station. The techniques learned from servicing Hubble were essential for building and maintaining the massive space station we have today. Tools had to be invented from scratch, specifically designed to work with bulky gloves in a vacuum environment. Imagine trying to repair a delicate watch while wearing thick winter mittens. That is the challenge of spacewalks. Hubble has orbited the Earth more than 150,000 times, traveling billions of kilometers. It has survived solar storms and computer glitches, always returning to operation thanks to the dedication of ground control. A dedicated team of engineers still watches over Hubble 24 hours a day, ensuring its safety. They have even uploaded new software to the old computers, teaching the old dog new tricks from the ground. Techniques were developed to run the telescope on just one gyroscope if the others fail, extending its life further. This adaptability is the true genius of Hubble's design. It evolves to meet challenges that were never predicted. Hubble revealed that our neighbor, the Andromeda Galaxy, is on a collision course with our own Milky Way. It allows us to see billions of years into the future, predicting the ultimate fate of our galactic home. It also made the first detection of an atmosphere around a planet orbiting a star outside our solar system. By analyzing the light filtering through the planet's atmosphere, Hubble found traces of water vapor on distant worlds. While it was not built to find aliens, Hubble has laid the groundwork for the search for extraterrestrial life. It has shown us the beautiful death of stars, creating colorful planetary nebulas that look like cosmic art. It captures the violent explosions of supernovae, which scatter the elements necessary for life across the universe. The carbon in our cells and the iron in our blood were forged in these stellar furnaces observed by Hubble. Hubble has taught us that we are physically connected to the universe in the most fundamental way possible. Every astronomy textbook in every school around the world had to be rewritten because of this single machine. It has inspired generations of children to become scientists, engineers, and dreamers who look up at the stars. Future telescopes will be bigger and more powerful, but they all stand on the shoulders of this giant. Working together with the James Webb Telescope, Hubble provides a complete picture of the universe in multiple wavelengths. It also monitors our own planet's atmosphere, tracking ozone levels and climate changes from its unique vantage point. It captures stunning views of auroras on Earth, reminding us of the magnetic shield that protects our world. Hubble has also been used to study the Moon, looking for resources that might support future human bases. As we prepare to return to the Moon and go to Mars, Hubble continues to scout the path ahead. The telescope is showing signs of age, and one day its components will finally succumb to the harsh environment. Eventually, gravity will pull it down, and it will burn up in the atmosphere as a final shooting star. But the data it has collected is immortal, safe in archives that will be studied for centuries to come. Scientists born 100 years from now will still be making new discoveries using the data Hubble collects today. Hubble is the ultimate testament to human perseverance, showing that we can recover from failure and achieve greatness. It reminds us that we are a curious species, always driven to push the boundaries of what is possible. From its high perch, it sees our world without borders, a fragile blue marble floating in the cosmic dark. Even now, as you watch this video, Hubble is locking onto a new target, gathering light from the past. Photons that have traveled for millions of years are ending their journey right now on Hubble's digital sensors. From the pillars of creation to the ultra-deep field, these images are the crown jewels of human achievement. It is a machine from the 80s that refused to become obsolete, a vintage explorer in a modern world. It remains a machine of the 20th century, still eloquently telling the story of 13 billion years of light. Thank you for joining Dark Sky Dive on this journey through time and space. Keep looking up at the stars.